Hello. Good morning, candidates. How are you? Now, I looked at how tough this day is, and I decided to record this lesson so that by the within the time of that lesson, you do and follow this very audio, and you do the best. So, we're still looking at integration. And today, we're going to look at case number 2 that includes quadratic factors. Remember last time, our case was linear factors, but today, we're going to look at quadratic factors. Now, I want you to realize that each quadratic factor, which is in the form ax squared plus bx plus c, in the denominator, which can't be factorized, has a corresponding partial fraction of the form ax plus b out of ax squared plus bx plus c, where we have a, b, c, a, b as constants. What do I mean by this statement? Here, in the denominator, the moment you find a quadratic equation, a quadratic expression that cannot be factorized, all right? That cannot be factorized. What you do, you just express that quadratic expression in this form, ax plus b. We are going to look at examples, and then we see how really we do it. Okay, we're going to look at examples, then we see how really we can do it. Let me write examples right away, and express f of x is equals to 2x minus 1 over in partial fractions Hence find integral to x minus 1 over x minus 1 dx. So the moment you look at this question really, you can see that in the denominator, we have a quadratic expression that cannot be factorized. But we saw how we deal with the linear polynomial or a linear expression. So this one which is linear, you will handle it. But this one which is not linear, it is a quadratic that can't be factorized. If you would factorize it, if it was like x squared minus 1, we're going to treat it like last time how we were treating it. Okay? It would be x squared, x minus 1, x plus 1. But this is x squared plus 1. It cannot be changed to any state. So what we do, we shall let 2x minus 1 over x minus 1 x squared plus 1, we let it equal to a out of x minus 1. You get this first one. You create its special fraction. Then this one, which is quadratic, we shall use bx plus c out of x squared plus 1. That is what we do. We let, the main thing is on this. You must let it be like bx plus something. You can use different letters, but since we are used to A, B, C, D, E, let's treat it like that. From here, if you take the LCM, it would mean that 2x minus 1 is equals to a into x squared plus 1, then plus x plus c into x minus 1. I've just taken the LCM, and the fact that the LCM here will be x minus 1, x squared plus 1, it will cancel with this. So I remain with 2x minus 1 is equals to a. You multiply this because you will kind of taken the issue of the LCM, all of it at once, then cancel the denominators. So the result is this. And after getting this result now, we can see how to eliminate and get value of A, how to eliminate and get values of B. So for this case, the moment you let x to be equaling to 1, the moment you let x as 1, it means that the whole of this will go and you can be able to get your A. So if I say putting x is equals to 1, it means that here we shall have 2 times 1, which is 2, minus 1. So it will be 1 is equals to x is 1, so it will be 2a. And you are going to get your A as a half. Then another thing here, we can put if you put x as 0 here, if you put x as 0, we are going to have, so in this case, you can have 2 equations which we are going to solve, simply because the reason as to why I'm doing that, I want to, because I still have 2 values, so I can need to solve them simultaneously. However, I told you there is an alternative of expanding this, then equate. But if you put x as 0, here it is going to be -1 is equals to the whole of this is 0 plus this. So it is A. Remember, you already have A. So it is A. Then this is 0, C, 0. So it is minus C. If you put a 0 in this, okay? But you already have what A is equal to. So we shall have that -1 is equals to A, which is a half, minus C. So you have -1 minus a half. So you'll have your C as a half plus 1, that is 3 out of 2. After getting C, look for B. Now, to get B, because we already have everything, okay, if we put X, if you put X as equal to -1, you put values that can eliminate the rest and you keep with a few of them. So if you let X as -1, here you will have 2 times -1 minus 1, that is -3 this side, equaling to, it will be -3 equaling to, -3 equaling to, when you put here -1, it is going to be 1 plus 1, that is 2 times A, that is 2A. If you put here -1, it will be, if you put here -1 minus 1, it will be -2, -2 times -B, so it was going to be plus 2B, then minus 2C. Just take time, substitute -1, but we already have A, B, so we can get C. Okay, so we can get B, sorry. So I wanted to substitute -3 is equals to 2A, to B, it will be 2 times a half, which will be 1 plus 2B minus 2C, which will be minus 3. So you're going to get your B as -1/2. Okay, so implying that therefore your f of x, after having gotten values of A, B, and C, f of x is going to be equal to 1 out of, because it is A over x minus 1, but A is a half, so it is going to be 1 over 2 into x minus 1 plus bx plus c. Now, for the case of this, since you have adding here, you first work on the numerator. So b is -1/2, so it will be -1/2 x plus c, which is 3 out of 2, but everything is over x squared plus 1. Okay? So when you work on the numerator, the LCM is 2, so it is going to be minus x plus 3, which is the same as 3 minus x over 2. So the whole thing is going to be 1 over, our f of x is going to be 1 over 2 into x minus 1 plus 3 minus x over 2 into x squared plus 1. This 2 I'm putting is, this one here is going to become 3 minus x over 2, then over x squared minus, rather plus 1. So this still comes here. Even if you work it out numerically or stepwise, it will come to that. So now we are going to integrate this. However, for those ones who have time and see, like maybe by induction, they fail to get values to substitute, I'm going to give you another different approach of getting the values here. So what you do after reaching here, just expand this so that you have your 2x minus 1 equals to ax squared, be ax squared plus a plus bx squared minus bx plus cx minus c. So looking at this, those ones which are quadratic, you put them together so that you have 2x minus 1 is equals to, factorize out x squared, so it will be x squared into a plus b plus those ones with x, put them together, so you have x into negative b plus c, then plus those ones without anything, without any value. So they are constants, we call them constants, so it is a minus c. And then you start equating. You will start equating the coefficients. Allow me use this side. So if we equate constants, rather coefficients, for x squared, this side we don't have anything. So I will say equate. For x squared, this side we have 0. There is no coefficient, so it will be 0 is equals to, this side we have a plus b. Then for the case of x values, the ones of x, we have negative b plus c. And this side we have 2. So we shall have 2 is equals to negative b plus c. Then for this case here, constants, here we have negative 1, and here we have a minus c. So for constants, we have negative 1 this side, which has no value of x. Then even the other side, the values which have no values of x is a minus c. Now, having this, you can solve these equations, and the main important thing is to use the substitution method. If you first work on these two, where you have, or you can work on any, then you substitute in the other. If you call this one equation 1, equation 2, and this one equation 3, you can deal with 1 and 2 first, where you have b, negative b, plus c is equaling to 2, and here you have b plus a equaling to 0. By adding, you can add these two equations so that negative b plus b gets 0. So you'll have, by adding these two equations, you'll have c plus a is equals to 2. And have c plus a is equals to 2. And then and solve this equation with this. Alternatively, you can make a the subject of the formula here. As well, you can make a the subject of the formula, or you can make b the subject of the formula, whichever. So you can say a is equals to negative b. Then you substitute this a, or you can substitute for negative b as a, then you solve that too. So still it is okay. Because if you substitute A as negative B, it means that where negative B is, you have A. So you will have 2 is equals to A plus C, and then you have negative 1 is equals to A minus C. So you can solve those. So still, you can solve the simultaneous equations. You will have the same answers. So allow me say, in the case you get challenges in solving simultaneous equations, you let me know. But I really think that everyone can. So now, after reaching here, I'm going to integrate this because they told me that hence I find the integral, meaning after expressing it into partial fractions, I find the integral. You need to note that the other values, let me see. You need to realize that the other values of 0, the values of 0, of x is 0, okay? And x has -1, they are conveniently chosen to find the remaining two other constants. Otherwise, the expression can either be expanded and coefficients of x's on either sides equated. So you can conveniently look for values that can easily get you the values of A, B, C, or you can expand and equate coefficients and then you solve the simultaneous equation there. So allow me move on to integrating. Now, remember I have my f of x as 1 over 2 into x minus 1 plus 3 minus x over 2 into x squared plus 1. Now, if I want the integral of f of x dx, it is going to be equaling to, I will factorize out this 1 over 2, then I say integral 1 over x minus 1 dx, plus even here I can pull out a half, sorry, then integral of 3 minus x out of x squared plus 1 dx. All right. Now, when you reach here, it becomes very, very, very fantastic. How? Because for this case, before I add on this, to be safe with my integral, allow me do this. To be safe with my integral, allow me do this. When you look at this, it's as if the function is 3 out of 2 of that minus x out of 2 of that. Okay, so what I'm trying to mean is 3 minus x over 2 into x squared plus 1 is the same as 3 over 2 x squared minus 1 minus x over 2 into x squared plus 1. In other words, you split it. You split it. It's like this over this minus this over this. So allow me say that this is the same as plus 3 over 2 integral of this is plus of 1 over x squared plus 1 dx, then minus a half, I will put out minus a half, integral of x up over x squared plus 1, then dx. Interesting. So this is the same as a half when you integrate, because I told you that when you differentiate the denominator and you find you get the numerator, it is automatically ln. So it is ln okay. It is going to be ln, then x minus 1 plus, right, to be plus 3 over 2. This is automatic. When you differentiate this, you get 1, which is this, implying that when you differentiate the denominator, you get the numerator. So that is ln that. But previously, we've seen how we integrate this, how we integrate functions of the form 1 over x squared plus 1. This is tan substitution. So without wasting time, just say tan inverse of x, right? Then the whole of this one now, remember, when you differentiate this, the reason is why I say it tan, because when you differentiate it, you don't get the numerator, so you can't use ln. The same applies to this. When you differentiate it, you don't get exactly the numerator. So I'm going to show you how I'm going to come up with minus a quarter ln x squared plus 1 plus a constant of integration. So I'm going to show you how I come up with these two. So let me give you a hint of when I was integrating 1 over x squared plus 1. However, I don't see any big problem, because that is what we have been doing occasionally. So we have been looking at how easy it is to integrate the functions that do involve tan substitution. So a case of having this, of course, this is the same as integral of 1 over 1 plus x squared, the same as, of course, dx, that is automatic dx, 1 over 1 plus x squared. Then we say that we let x to be equal to tan theta, maybe, meaning that our theta, if x is tan theta, then our theta is tan inverse of x. And then it would mean that our dx here is equals to sec squared theta d theta. So when you substitute here, it is going to be the integral of 1 over x squared. Now, if x is tan theta, then x squared will be tan squared theta plus 1, then times dx, which is sec squared theta d theta. But remember, tan squared theta plus 1 is the same as sec squared theta. So they cancel, so we shall have d theta. It will be integral of d theta. But we say that when we integrate d theta, we get theta. Now, and the theta is tan inverse of x. So tan inverse of x, which is this. Then for the case of integrating x out of x squared plus 1 dx, what you do here, we shall let maybe x squared plus 1 to be equaling to u. So that 2x dx, when you differentiate 2x dx, this side is going to be equal to du. And therefore, our dx is going to be equaling to du out of 2. So if our dx is du out of 2, it would mean that that is what we are going to substitute here. So our integral is going to become x, shall keep it as x, out of x squared plus 1, it is u, times our dx is d over 2, actually d over 2x, du over 2x, so that this x goes with this, and I will remain with the du, integral of du out of 2u, of which I can move out a half, so it will be a half integral of 1 over u du, but 1 over u, when you differentiate u, you get 1, so we shall have ln u, so it is going to be a half ln, going to be a half ln u, but remember, u is x squared plus 1. So it is going to be, that's why you see me having negative a quarter ln x squared plus 1, because this a half, found this negative a half, it became negative a quarter, and that is how we come up with this. So you have to be technically smart to come up with that expression. And with this regard, I would really love that since we have known how to come up with that, the rest of other things are very okay. And I would challenge everyone. I would challenge everyone to do this. I would challenge everyone to do this. I will express it into partial fractions, and then I let everyone integrate. Express as a partial fraction. Hence, find the integral of x squared minus 3 . So what you do with this, you have to let x squared minus 3, x minus 2, x squared plus 1 to be equal to a of x minus 2 plus bx plus c over x squared plus 1. Take the LCM, cancel them. You have x squared minus 3 as a into x squared plus 1 plus bx plus c x minus 2. So the main thing here, if you don't want to spend time substituting, you can expand so that you have x squared plus a plus bx squared minus 2bx plus cx minus 2c. Then you factorize out according to the powers. The ones of x squared is a plus b, so you have a plus b into x squared. Then plus those ones with an x only, it is c minus 2b, or minus 2b plus c, whichever, c minus 2b. Then the ones with the constants only, it is a minus 2c. So here you can equate the coefficients. If you equate for x squared, when you equate x squared, equate coefficients. When you equate for x squared, here you have a plus b, and this side you have 1. The coefficient of x squared is 1. For x, the coefficient, so here was supposed to be x, it is c minus 2b equaling to this side, you have 0. We don't have any coefficient of x, so it is 0. Then for constants, you have a minus 2c, and this side you have negative 3. So you can solve these equations. You can make any of the subject here. You can say a is equals to b minus 1, rather 1 minus b. This is your equation 4 maybe. Then you bring this equation and substitute it as b here, so that rather you substitute for a and then you solve. So if you substitute for a here, it's going to be 1 minus b minus 2c is equals to 3 negative, so that your negative b minus 2c is equals to negative 4. So you will solve this equation with this equation because they have the same values. So I'm not going to do that, but you will come up with a as a fifth. You are going to come up with b as 4 over 5, and you are going to come up with c as 8 over 5. So that your whole function becomes x squared minus 3 over x minus 2, x squared plus 1 is equals to a, the value of a to be 1 over 5 into x minus 2 plus bx. Bx, just first substitute, it will be 4 out of 5x, then plus c, which is 8 out of 5. Then everything is over x squared plus 1. So the whole thing is going to reduce to 1 over 5 into x minus 2 plus 4 over 5 plus 8 over 5. It will be 4. One can write it as x plus 8, 4x plus 8 out of 5 into x squared plus 1. All right, one can write it like that, or else here even one can factorize further and says 1 over 5 into x minus 2 plus 4 into x plus 2 over 5 into x squared plus 1. All right, so going ahead to integrate this is something which is very, very, very easy. It's something which is very, very, very easy. How? Because it's a matter of substituting, rather it is a matter of integrating this. And let me show you how. Remember, our function has become 1 over 5 x minus 2 plus 4 into x plus 2 out of 5 into x squared plus 1. So the integral of that function dx will be equaling to the integral. We put out 1 over 5. So it is going to be 1 over x minus 2 dx plus, can put out 4 over 5, integral of x plus 2 over x squared plus 1 dx. This one should not worry you too much because we are going to split it as x over this plus 2 over that. So it is going to be 1 over 5, 1 over x minus 2 dx plus 4 over 5. Since 4 over 5 is affecting everything, I can say into integral of x over x squared plus 1 dx plus 2, because it is 2 over this. So I can say 2 integral of 1 over x squared plus 1 dx. So this one is going to give me 1 over 5 ln. Why ln? Because when I differentiate this, I get 1. So it is going to be ln x minus 2 plus 4 over 5. When you integrate x over x squared plus 1, you get a half ln. Why a half ln? If you let u to be equaling to x squared plus 1, to mean that du is going to be equaling to 2x dx. So my dx is going to be equaling to du over 2x. So that the integral becomes integral of x out of, instead of x squared plus 1, I write u times dx. Instead of dx, I will write du out of 2x. This one will cancel. So I'll move a half outside, so it will be a half integral of 1 over u du, which is a half ln u, but u is x squared plus 1. So that's why I was telling you that this one becomes a half ln x squared plus 1. Then plus 2, when you integrate this, you get tan inverse of x, everything plus a constant. Because this is in the same way when one writes 1 over 1 plus x squared, which is the tan substitution expression. So from here, you can really see that you're going to have 1 over 5 ln x minus 2 plus, you can enter this, so it will be 4 over 10, which can be reduced. Okay, 4 over 10 can be reduced as 2 over 5, because this is 4 over 10. 4 over 10, which can be reduced as 2 over 5. So plus 2 over 5 ln x squared plus 1, then plus 8 over 5 tan inverse of x plus the constant of integration. That is it. That is it that we are having. That is it that we are having. As simple as that. Simple as that. So I'm going to do you more 2 examples. I'm going to do you more 2 examples. Number 3. Evaluate from 2 to 3 of x squared x power 4 minus 1 dx. This number seems to be very easy. This number seems to be very easy, but it may not be. It may not be. So here, you need to really know that only this, the numerator, you need to know that this is the same as solution. You need to know that this is the same as, well, this is the same as, if it is x power 4 minus 1, one can write this as x squared plus 1 times x squared minus 1. If you expand this, you should get this. So x squared, it is the same as that. But then this is the same as also, this one is not factorizable, so you leave it like that. Then x squared minus 1, this is the difference of two squares. So it is x plus 1 times x minus 1. So we are going to substitute here with this. Okay, now it means that if I put in the limits, okay, if I put in the limits, it would mean that just only x squared over x power 4 minus 1 is the same as x squared out of x squared plus 1, x plus 1, and x minus 1. So if I put it into partial fractions, it means that x squared over, I can begin with these ones, can begin with x minus 1, x plus 1, and then x squared plus 1, and this is going to be equaling to a out of x minus 1 plus b out of x plus 1 plus, now it will be cx plus d. Because of this, but now you don't say bx plus c plus, yet you have used b already. So cx plus d out of x squared plus 1. So when you multiply through by the LCM and you equate, you are going to have x squared is equals to, it will be a into x plus 1 into x squared plus 1 plus b into x minus 1 LCM, then x squared plus 1, then plus cx plus d into x minus 1 x squared plus 1. So here by substituting, by putting, it will not work out, but you can expand this expression. And after expanding this expression, you get the rest of the values. Even by putting, you can get, because you can really see that if you substitute x as 1, this one will go, and this one, all of it will go, because this one will be 0. If you put x as 1, the whole of these ones will go. So whatever you substitute at the end, you are going to get answers. But I want to also get you used to the other one of equating. You can get used to the one of equating, but still at the same time, substituting can give you the answers easily. Because if you substitute, anyway, let us use two alternatives. Let's first expand. If you expand this, you're going to have x squared is equals to, when you expand here, you'll have a into x cubed plus x squared plus x plus 1 plus b. When you expand the ones of b, you're going to have x cubed minus x squared plus x plus minus 1. When you expand this one, all of it, you're going to have cx cubed plus dx squared minus cx minus d. So you can factorize out, so that x squared is equals to the ones of x cubed, you put them separate. It is going to be a plus b plus c, because you have x cubed, you have bx cubed, you have cx cubed. So you can, it is a plus b plus c into x cubed. Then plus the ones of x squared, it will be a minus b plus d into x squared. Try looking at it. Here you have ax squared, here you'll have minus bx squared. That is why I've used minus. Then here you'll have plus dx squared. So that is why I have this. Then the ones of constants, rather the ones of x, you have ax, so you have a plus bx, so you have b. Then you have negative cx, so you have minus c into x. Then the ones of constants, you're going to have a minus b, then minus d. So now from here, you can equate. You can equate for x cubed. When you equate for x cubed, this side you have 0. So it is 0 is equals to a plus b plus c, equation 1. When you equate for x squared, this side you have 1 only. So you have 1 is equals to a minus b plus d. Then when you equate for x, this side you have nothing. Rather, this side you have nothing. When x, so you have 0 is equals to a plus b minus c. Then when you equate for constants, this side the constants you have a minus b minus d, but this side you have 0, constants 0. Now, the moment you solve these simultaneous equations, you should be able to get the values of a, b, c, and d. But to make your work easier also, someone can let alternatively, if we substitute, or if we put x as 1, it means that if you put x as 1, here the b's will go, the whole of this, because it will be 1 minus 1, which is 0, the whole of this is 0, 1 minus 1, which is 0, the whole of this one will become 0. So if you substitute x as 1, we shall get the value of a faster, because it will be x as 1 here, it will keep 1 this side, is equals to a plus b plus c times 1. So when you put x as 1 here, we are putting into this here. If you're expanding, if you want to substitute, you don't expand. So it is going to be 4a. And this one will give you your a as a quarter. And if you put x as 1, you get your a as a quarter. All right. Then if you substitute x as negative 1, if you put x as negative 1, it means that here it is going, the whole of this is going. Because it would be negative 1 plus 1, so it takes away all this. So here you have, we shall have equation, right? We shall have the equation. And this side, we shall have 1, because it will be 1 and negative 1 squared, which is 1. So we're going to have 1 is equals to Try substituting wisely. Try substituting wisely and see. So it is going to be B into -2, all right? Because it will be -1 minus 1, which is -2, then into 1 plus 1, that is 2 into 2, then plus -C plus D into, this is -1 minus 1, -2 into 1 plus 1, which is 2. So this one will give you 1 is equals to -4b this is -4 times that, so it will be minus 4c, then minus 4d. Okay, so you can call this one equation 1. Since you've already gotten A, others will be easily found. So if you substitute x as 0, if you put x as 0, you're going to eliminate some other things, you form another equation. You also substitute for x as 2, you eliminate and you form another equation. Okay, so on coming up with those equations, you are going to have your A. I'm challenging everyone to solve these equations. It's a matter of substituting, because there you have A, B, C, but there is a D. So you can remove D and you make it a subject of another equation and you solve them. I want you to find out if you will get A as anyway, what you can do easily, if I'm to give you a hint on solving these equations, what I can give you as a hint, you get equation 1 minus equation 2, because these ones can easily keep a C only. If you get equation 1 minus equation 2, A will go, B will go. So they are going to reduce. Then after that one, you see how to solve. You see how to solve them. You get your A as a quarter. You get your B as negative a quarter. You get your C as it will give you C as you get your C as 0, and then you get your D as negative a half. So those are the values that you're going to get, and then you take them for solving. Remember, we have gotten A, B, C as that. So our integral or our expression, x squared out of x minus 1, x plus 1, x squared plus 1 has become A. We got A as a quarter of x minus 1, then B plus B, which is negative a quarter of x plus 1, then our C is, we have gotten it as 0, and it was Cx, so it is 0, then plus D, which D we've gotten as negative a half. So we shall say negative a half. Actually, our value of D is supposed to be a half. So you check very well, it is supposed to be a half. you check and read and do it very well, into x squared plus 1 dx. So it means that our integral of x squared out of that dx is going to be equaling to a quarter integral of 1 over x minus 1 dx minus a quarter integral of 1 over x plus 1 dx plus a half integral of 1 over x squared plus 1 dx. And looking at this, this is going to be a quarter ln x minus 1 minus a quarter ln x plus 1. I'm using lns because when you differentiate this, you get the numerator. Then for this, it is a tan substitution, it will be plus a half tan inverse of x, then plus c. But they are given us limits. Therefore, the integral from 2 to 3 of x squared over x power 4 minus 1 dx is going to be equaling to, just substituting the limits, a quarter ln x minus 1 minus a quarter ln x plus 1 plus a half tan inverse of x from 2 up to 3. This one is, I can move out a quarter, regardless of it not being here, but I can move it as a quarter into ln, then it will be x minus 1 over x plus 1. I told you that you treat ln as logarithm. Since you're subtracting, you'll be dividing. Then plus, this was a half, but I put out a quarter, so it will be 2 tan inverse of x. So that when you enter this, it becomes a half again. Then from 2 up to 3. So looking at these members, it's going to take you far. It's going to be a quarter. First substitute 3. So it is going to be a quarter ln you first put a 3 everywhere, so it is going to be ln. When you put here 3, it's going to be 3 minus 1, which is 2, over 3 plus 1, which is 4, then plus 2 tan inverse of 3. You first put a 3 only. Remember, this a quarter is for everything. So minus ln, when you put a 2, it will be 2 minus 1, which is 1 out of 3, plus 2 tan inverse of 2. This is going to be a quarter into, when you work on this, you're going to get 0.405 plus 0.1 pi. It's better you put your calculator in radians, and this one will give you 0.18. Or you can just put it direct on a calculator the way it is, and then you get your answers. Get an answer here, get an answer here, multiply by a quarter. So say a quarter into what you get here plus what you get here or minus what you get there. So you get 0.18. Then from there, let me do another example. Show that, this is my last example. Show that the integral of 0 up to 1 of x squared plus 6 x squared plus 4 x squared plus 9 dx is equals to 5/20. Realistically, all of these ones are quadratic factors and they can't be factorized. Therefore, we shall simply say let I've done well recording because the rain has taken away power. But this is very amazing. We're going to let x squared plus 6 out of x squared plus 4 times x squared plus 9. We're going to let it be ax plus b out of x squared plus 4 plus cx plus d out of x squared plus 9. The same. So this is going to be equal to x squared plus 6 is equals to, it will be ax plus b into x squared plus 9, then plus cx plus d into x squared plus 4. So this is x squared plus 6 is equals to, when you expand and factorize, I'm giving everyone a role. You expand it, then we collect the coefficient. So it will be a plus c into x cubed. You have to do this after expanding, plus b plus d into x squared plus 9a plus 4c into x plus b plus 4d. So if you equate coefficients, for power 3, this side we have 0, but this side we have a plus c. So it is a plus c equaling to 0. Then for x squared, we have b plus b. And this side we have 1. Then for x, we have 9a plus 4c. And this side we have 0. Also, we don't have a coefficient of x. Then for constants, this is why we have b plus 4d. as equals to 6. So really you can see that you can solve this equation and this equation. You can solve this and this because this is b plus d, this is b plus 4d. So you can solve that simultaneously. Then you can see a plus c, 9a plus 4c. Still, you can solve this one simultaneously. And after solving this equation simultaneously, take your time. You're going to get your a as 0. You get your c as 0. And you're going to get your b as 2 out of 5. And you're going to get your d as 3 out of 5. So when you integrate that, when you substitute, it means that the integral, anyway, the whole thing x squared plus 6 over x squared plus 4 into x squared plus 9 is going to be equaling to ax. A is 0, so we have b, which is 2 over 5, so it is 2 out of 5 into x squared plus 4. Right, then plus cx, c is 0, so we have plus d, which is 3 over 5 into x squared plus 9. So that the integral of 0 to 1 of x squared plus 6 out of x squared plus 4, x squared plus 9 dx is going to be equaling to 2 over 5 out, then integral from 0 to 1 of 1 over x squared plus 4 dx, then plus 3 out of 5 integral from 0 to 1 over x squared plus 9 dx. So all these ones, they give you tan substitution because this is the same as 4 plus x squared. This is the same as 9 plus x squared. We saw how we work it out with the tan substitution. And allow me to say that this is the same as, that this is the same as, however, I want you to give it time and integrate it the way we have been doing for tan substitution. So it is going to give you 1 over 5 out, tan inverse over half x plus tan inverse over third x from 0 to 1. So you have to be technically careful when you're working on the integrals. I want you to work it out because we learned the tan substitution and see if you're going to come up with this. So this is the same as a fifth tan inverse of, because tan inverse is common, so I can say tan inverse of, then work out when x is 1. When x is 1, it's going to be equal to a half plus a third. Of course, when x is 0, you will also substitute over 1 minus a half times a third. This one we get it from the expansion of tan plus tan, which is tan plus tan over 1 minus tan. From your trigonometry, you need to know, or you need to remember the effect of tan when you're working on tan. All right. You need to know that when you're working on tan of something, It's the same as, it's like when you're working on tan of x plus y. The same as tan x plus tan y, 1 minus tan x and y. But I've already pushed out a tan. So it is a half plus a third over 1 minus a half times a third. All right, then cos minus 0, because all these x, if you substitute x as 0, the whole thing would be 0. So this is going to be a fifth. You put your calculator in radians and you take the tan inverse of what you get here. Or you can leave it in degrees, but you take the tan inverse of this, you're going to find yourself with a quarter pi, which is the same as 1 over 25. I want you to put in some good mathematics here. You shouldn't just leave it like that. You shouldn't just leave it like that. I want you to know how everything has come, and that is it by you putting your own check. You put your own check. I'm going to give you an exercise which I want you to do. I'm going to give you an exercise which I want you to do. And in this exercise, I want you to integrate I wish you well. See you tomorrow. I wish you well. See you tomorrow.